So again, we barely started this yesterday, so you might just want to continue on with your notes. I want to find a problem that works nice. What does your book call this section? Oh, they just call it matrices. Okay. This is not an equation. This is just some random matrix. This is not an equation. It is just some random matrix. If it was an equation, you'd have to transfer the equation into a matrix. That's not what we're doing. I'm just giving you a 2 by 2. 2 by 2, what's that mean?
2 rows, 2 columns.
2 rows, 2 columns. You're always going to see it written as R. You're never going to write out the word row. Okay. No, sorry, I'm going to change that. Let's do 5. This means take 5 times row 2 and add it to the existing row 1. Multiply row 2 by 5 and add to the existing row 1. That's what that means in words. Yep.
So you're trying to get to the 1, 0.
No, not yet. I'm just doing basic operations. This is not an equation.
So what are you trying to use?
Just doing some adding and subtracting. Just doing some adding and subtracting.
That specific one?
Pardon me?
How did you know?
I made it up. This whole thing is being made up.
Oh.
Okay, a couple ways you can do it. Some people like to rewrite. Some people do the whole thing in their head. I'm going to rewrite it. What's 5 times row 2?
0.
0 what? 0, 15. This is 5 times row 2. Here's row 2. 0 times 5 is 0. Excuse me. 3 times 5 is 15. Yes? So I'm now going to add that to row 1. The original given row 1 is 2, -4. That hasn't changed. 2 plus 0? 2. -4 plus 15? 11. And then I go back to the existing row 2. Some people like to do the whole thing in their head. That's fine. All right? Let's do double operations. So let's say you have, let me stick with 2 by 2s for right now. They're obviously easier. How about -1, give me a number.
2.
2, give me some more.
5.
3.
Can I make one of those negative?
Okay, 5.
-3.
I'll choose. How about -5? Okay, so let's do plus 3 times row 2, and let's do, bless you, plus -4 times row 1. The alterations come from the beginning matrix. The alterations come from the initial given matrix. So, which you want to do first? You want to do row 1 or row 2? Who cares? Which one?
Row 2.
All right. Ryan wants to do row 2. Okay, so I'm going to take -4 times R1. I'm going to show all the steps. What's -4 times row 1?
4, -8.
This right here is -4 times the given row 1. Now I'm going to add that to row 1. I'm gonna add row 2 to the now changed, the altered row 1. So what is the altered row 1 plus row 1? Oh, sorry, plus the negative 5, 3, sorry. What is that? And I'm gonna go back to the given. So this is the altered row, this is our new row 2. And this is the given row 1. Yes? Everything goes back to the given. So row 1 is now going to be 3 times row 2 from the given row 2, not my altered row 2, from the given row 2. So what is 3 times the given row 2? This is super confusing how I'm writing it. Can I just write it underneath? Can you handle that?
Yes.
Yeah? Okay. So what is 3 times row 2?
Negative 13.
And now I'm going to add that to the given row 1. So what do you get? What do you get?
Negative 16.
11. Then the new row 2, which is negative 1, negative 5. I think it's helpful if you label like the given versus the change, the altered, whatever. Okay? That's basic matrix operations, which you need to do, you have to know how to do that for solving with augmented. By the way, what is that? What's ax plus by equals c? Standard form of a line. Yeah, standard form of a line. They're just different variables. That's still a standard form of a line, just different variables, that's all. All right, coefficients. What are the coefficients of the first equation? A and B. What are the coefficients of the second equation? D and E. So I'm going to create what they call a coefficient matrix. Last year, did this. Not augmented, but you did inverse matrices last year. Only 2s went into inverse matrices with 3. This is the coefficient matrix. I need to multiply that by, need another matrix to multiply it by.
X and Y.
X and Y. Bless you. It's called the variable matrix. That needs to equal to something. What's left? C and F. And we call that the solution matrix. The answer matrix, the solution matrix. I'm going to use answer because it takes less marker. Haha. How do you multiply matrices? How do you multiply matrices? No?
Cross them out. So A, X, and B, Y.
There you go. Cross the row down the column. We learned to multiply matrices, no? Let's do a quick review of that. Three rows, one column. Okay, I'm going to make up another matrix, but it has to have certain qualities. What must one of the qualities be?
3 rows.
3 columns.
No? It has to be a 1 by something. It has to be a 1 by something. The number of, have some rows, I shouldn't use X. I should use R. I guess it doesn't matter. Rows by columns of matrix A. So you have rows by columns of matrix A. If you want to multiply that, then the columns of B must match the columns of A must match the rows of B. These must match. The columns of A must match the rows of B, otherwise you can't do any multiplication. Columns of A must match the rows of B. So this is one column. So my next matrix, what is the numbers? This is a 1 by 4. They must match. What do the 3 and the 4 tell you? We remember nothing about matrices? What's the 3 and the 4 tell you?
The answer.
What about the answer?
It's gonna be a 3 by 4.
Yeah, this is the dimensions of the answer matrix. Multiplication with matrices is not commutative. Multiplication with matrices is not commutative. So I am going back to this, but if you can't multiply matrices, then you can't do the next step here. So let's multiply out 3, 2, 1, 0, negative 4, 6, 7. How is that going to turn into a 3 by 4? How is a 3 by 1 and a 1 by 4 going to turn into a 3 by 4? How's that possible? Where do I start?
3 times 0.
3 times 0. Yeah? Across down. There's nowhere to go across from the 3, and there's nowhere to go down from the 0. That is your entry. What's the next one? Well, it depends on which way you go. Let's go across the row. First row, first column. Let's do first row, second column. What do I multiply to get the first row, second column?
3 by negative 4.
3, negative 4. Done. What do I do to get the first row, third column?
3 by 6.
3, 6. And what's the next one?
Times negative 7.
3 times 7. Okay, there's your first row. Okay, finish it off. And then, of course, multiply that out. That's not done. I showed all the steps because I'm going to show you what that means. Rows, columns, My first row, 3, 3, 3, 3. First row. Second row, 2, 2, 2, 2. Second row. Third row, 1, 1, 1, 1. It's not a coincidence. First column, 0. Second column, -4. Third column, 6. Fourth column, 7. Always lines up that way. Always. 0, 0, 0. Yeah? If you go by the columns. 0, 0, 0. -12, -8, -4. 18, 12, 6, 21, 14, 7. Yeah? You wouldn't write it that messy. So let's go back to this purple thing. Beginning of the row, top of the column. AX, across down, BY. AX, BY. You always add in between. AX plus BY. First row, first column. First row, first column, C. Beginning of the row, top of the column. DX, EY. DX, EY. Second row, first column. Second row, first column is F. So, if I give you an equation to solve, and now I'm going to look one up because I don't want it to be nasty. Here we go. X plus 2y equals 5. And x plus y equals 3. Now, very clear. Never solve this by augmented matrices. I would use elimination, I would subtract, and I would say y is 2. Yeah?
Yeah.
Hopefully, right, by elimination. Subtract the 2, x minus x gone, 2y minus y is y, 5 minus 3 is 2, y is 2. Yeah?
So you only use the matrices if you can't solve it by just.
No, you have to use matrices. When I tell you, you need to solve by matrices. You need to know how to solve by substitution, elimination, which I didn't review. You need to know how to solve by graphing, like intersecting two lines. You need to know how to solve by inverse matrices, which I'll review a little bit, but that was done last year. You need to know how to do augmented matrices, which is this, and you have to know how to do determinants. There's 7 ways, 6 ways, 3 of which you learned in Algebra 1 last year, Kramer. There's 6. Oh, then there's the calculator. There's 7 ways, which of course, given a choice, I'd use my calculator instantly. But of course, you know that's not going to be an option. Yeah.
But in the book it says that you have to solve using the matrices.
Oh, this is augment. This is matrices. Matrices.
So you're saying you would usually
No.
solve.
What I'm saying is, given a choice, I would never use matrices. Given a choice, I would do it in my head and I would say y is 2. Yes? But that's not, you aren't given a choice because I'm not that nice. You have to do it with augmented matrices. Yeah? Okay, so let's create the coefficient matrix. Create the coefficient matrix. Oh, this is a nice eraser. Did somebody lose an eraser yesterday? It's a nice one. You might want to say, I lost an eraser yesterday. Some of you need an eraser. Kavi, you need an eraser.
I have been scratching stuff out of my test.
Okay. What's the coefficient matrix?
1, 2, 1,
1, 2, 1, 1? Yeah? Okay. Sorry, I'm erasing. All right, what is the answer matrix? Forget about the coefficient. Forget about the variables for right now. What's the coefficient matrix?
5,
5, 3.
I misspoke like 15 times. You already told me the coefficient matrix. Coefficient matrix is 1, 2, 1, 1. What is the answer matrix, solution matrix, whatever?
5, 3.
Okay. So instead of writing it as a separate matrix, you put it all together as one large matrix. This is not the matrix, it's the whole thing combined. Do you remember from yesterday what I need to do to the coefficient matrix?
Make it 1, 0, 0.
Yeah, make it 1, 0, 0, 1. What's that called? Did I tell you what it was called?
Identity
Identity
matrix.
matrix.
This is the identity matrix. Why the identity matrix? Because, excuse me, you have x, y, excuse me, 1x plus 0y. What's 1x plus 0y?
X.
X, perfect. X will be whatever we solve for. 0x plus 1y. Excuse me. What's 0x plus y? Y. That'll give us what we need. Okay, so now we need to do some manipulations, which is what we did the very first thing in class. You know, row 1 times 6 plus row 2, or whatever. Where do you start? If you remember from yesterday, where did you start? Where did you start?
Row, bottom, that, right, that, left, down.
That. How about row 1,
The one
column 2?
closest to you.
Row 2,
2,
column
column
1.
1.
Thank you. Row
Yes,
2.
Row 2, column
How am I going to make that 0? Yeah, you don't necessarily always have to do multiplication. Sometimes you can just do subtraction, which, by the way, when I was like, I would never use matrices, I would just subtract, yes? Can I just subtract? Yeah? Tell me what to do.
1. Row 2 minus
Row
row
1.
Row 2 minus row 1,
Yeah.
and I'm going to put that answer
In the second.
in row 2. So I'm not gonna, this is going to be row 2 minus row 1, and it's going to go in my second row. David,
Wait, I think if you did row 1 minus row 2, that'd be easier. 'Cause then
if you did row 1 minus,
Oh, yeah.
Yeah.
oh, the other way, yeah, then I could avoid negatives. Yeah, absolutely. Both are correct, but I agree with you. That's a bit easier. Sure. All right, what's row 1 minus row 2? So, row 1. 1 minus 1 is nice. Row 1, 2 minus row 2, 1. What's 2 minus 1?
1,
Oh, nice. 5 minus 3.
2.
And I'm going to go back to the original row 1. Well, that's nice. Half of our identities done. 0, 1, y is 2. All right. Well, this is pretty good. I have a 1 here. Fantastic. 0, 1. It's got to get rid of this 2. I just need to get rid of this 2. That needs to be a 0. So I should just divide 2 over 0 and get 0.
Can you do
Hell no. Jason.
Can you do row 1 equals row 1 minus 2 row 2, or 2 times row 2?
Yes. Can you say that a little bit slower so we can write it down?
Row 1 equals to row 1 minus 2 row 2.
The second row is done. Don't alter it. Second row is done. Don't alter it. Okay. 2 times row 2. What's 2 times 0?
0,
0. 1 minus 0 is
1,
fantabulous. 2 times row 2. What's 2 times 1?
2.
2. 2 minus 2 is
0.
woohoo! There we go. 2 times row 2. What's 2 times 2? 4. 5 minus 4 is,
1.
you can check. Not your answer. Not your answer. What's wrong with this answer?
That's equals to 1, y equals to 0.
Okay, so I don't like that either. It is true, yes. X equals 1, y equals 2. What's that represent?
Coordinate point.
It's a coordinate point. It's a coordinate point. Your answer is 1, 2. If you do not write your answer as an ordered pair, you will not get full credit. Make note to yourself. If you don't write your answer as an ordered pair, you're not going to get full credit. Yeah, Jason.
How would we write it as an ordered pair with X, Y, and Z?
An ordered triple. Ordered triple. We're not going to do augmented with 3. It's pretty intense. Let's do one more. What? We'll do it on the calculator.
That's what I was struggling with last night.
Yeah, the homework from my last time.
We can do it. You want to try one?
Sure.
Yes.
Okay. I'll tell you that I have not done an augmented 3x3 since I was in high school. So,
What about last year?
I didn't teach trigonometry. We don't teach augmented in trig regular, and I didn't teach trig honors last year. So there you go. All right, let's go. Let's challenge my brain. Let's see how much I remember.
But we will be tested on it.
Maybe, maybe not. Okay, here's a good one. What if I said no? Then you're not going to pay attention and listen. So I say yes to everything, and then I get in trouble because you lied. You said it was on the test. So I don't answer. I plead the fifth. If I do it in class, it's fair game. All right, here we go. Oh, no, I don't like that one. Well, I want it's harder when
Can you
there's...
do one that's more questions than a question?
Sure.
Yes. Can you
55.
If I see
show
B.
55?
51.
55.
Or just do all of them?
What's 55? What's the answer to 55? Do you know?
I
It's in
Like-
C.
like
You get like 2 equations that are the same thing.
yeah.
Oh, so it's consistent.
What?
Is that what one is?
Consistent means that it's essentially the same line.
But there's
Consistent means it's the same line, but it depends. There can be like an answer for X and Y and then a consistency with Z. Is that what happens with 55?
Yeah, 55 y equals
Just
4
do
z minus
51.
3, and then x equals 5 z minus 2.
Hold on. What'd you do? What's 55?
you guys.
Oh, so Z,
yeah,
so Z is
Y and Z.
consistent.
Why did they choose
51,
51 y.
51 has a nice X, Y, and Z.
We should do 51.
Let's do 51.
Here we go.
Wait, I do
It's going to take a lot of space. I can tell you that already. Always start at the bottom. Always start in the bottom row. Always start in the bottom row. All right, 51. Ready to catch all my mistakes?
Yeah.
Hope so. Make sure I write it down right. All right, take a quick look. Make sure I wrote it down right. If I wrote it down wrong, then we're doomed. I'm starting in the bottom. I'm going to start with the 0, with the -3. You have so many options. Sometimes too many options is not good. I'm thinking, just looking at it, here's where I'm going to start. I'm thinking I'm going to do row 1 times 3 and add it to 3. That's where I'm thinking. That's where I'm going to start. Yeah, Joshua.
So is the goal the identity?
Yeah, absolutely.
But how does it work with the
Same exact way. Same exact with just an extra row. 1, 0, 0, 0, 1, 0, 0, 0, 1. Row 1 times 3 plus row 3. This is now going to be 3 times row 1 plus row 3. Is that what I said?
Yeah.
Yeah? Okay. So, the only thing that's going to be altered after we do our operations, the only thing that's going to change is row 3. So I'm just going to rewrite row 1 and row 2. Okay? 3 times row 1. And I'm going to erase as I go along. Plus 2. 3 times row 1 is 3, -6, 9, 21. Yes? If I make a mistake, you really need to tell me right away. Otherwise it's gonna be horrible. 3 minus 3 is 0. Cha-ching! We're 1/9 of the way there. Oh, that's not true. We have this one right here. Oh, we're in good shape because we have this one, that one. It's got 9s. -6 plus 2 is -4. 9 minus 2 is 7. 21 minus 10 is 11. Yeah,
Do we have to write 3 on 1 plus 1?
you should. Because if I can't follow your work,
It's clear enough.
what do you mean if it's clear enough? Like if you go from here to here with nothing written for me, that means I have to try and figure out your operations. And your homework, do you have to? No, but I would recommend that you do so you get used to writing it for a quiz or a test. All right. Next, I'm going to look at -4. Okay, I'm thinking -2 times -2 is 4, plus -4 is going to give me 0.
Minus.
Yeah, plus negative, yeah. So I'm going to take, I'm just going to rewrite again. I'm only altering in the big picture. There are a couple ways to do this. I'm just doing it this way. So I'm going to take -2 times 2 and add it to row 3. So that's going to be -2 row 1 plus row 3. Yeah,
So it wouldn't matter if you put 2 times row 1 minus row 3.
correct. All right, -2 times row 1 is -2, 4, -6, -14. -2 times row 1. Yeah. -2, oh no, that's not going to help me. I just messed that up. That doesn't help because -2 plus 0 changes this to a -2, and that's not what I want. That's not what I want. Nope. I'm gonna try something different. Oh, you have a whiteboard, it's super easy. Yes.
It gets a 1 in the where the 7 is though. Because it would be -6 plus 7, which would give you the 1. in
Go
the
back,
first
where are you
row.
at? Where's -6?
Well, with the operation you just did, because if you do -2 times the first row, it'll give you -6 for the 3. And if you add that to the 7, it'll give you the 1 that you need in that area.
Okay, go back, start slower.
Okay,
I
so,
believe you, just slow down.
So if you multiply the first row by -2, and then you
Wait,
add it
multiply the first row by -2, which is what I have.
and then you add it to the third row, you
Right.
get a 0, and then you get a -2, 0, 1, and you have your 0 and your 1 from the that you need.
But I need to get rid of this.
You just add it, right?
Then you can add it to
Add
row
it
2.
1 there.
Oh,
Yeah, but then you
Oh,
skip
Then
it.
I
mess
can-
up.
no, because then this changes to a 1.
We should do in a step before. We should do -2.
This
we should
row,
do
this step, or this step?
the second step. Where we should do
Huh.
row 2. We should do row 2 minus 2 row I. 1. So that you can get the
You're good
first-
here?
Yeah, so you can get 1, 0, 0 in the first column.
In the first column, 1, 0, 0.
So that in the second row,
So what do I need to multiply by?
then you would multiply the first row by the -2,
Which is what I did.
You know what?
and then you would add it to the
Second row.
And now, okay, so you want to do it that way. So Mr. Perryman, they really wanted to do a 3x3 augmented.
Let them do it.
I told him I haven't done a 3x3 augmented since I was in high school.
You could just find a 3x3 system in the book that you know has integer solutions. Yeah, and then just kind of grunt through, and you never have to do the whole thing. You can always just do the lower triangle
That's what we're trying.
and work your way backwards. Right?
That's what we're doing.
Okay.
We're making some mistakes along the way, but that's okay.
That's how you learn.
That's exactly right. All right, so let's go do it.
But then you screw up the one in the middle.
It's fine.
Yes.
It's fine.
We'll change it later.
We'll change it later.
No, because it becomes 0, 5, -5, -10, and you can divide by 5. So you get it back.
So you want to do row 1, row 2 like Ryan said, or we want to do row 1, row 3 like somebody else
So
said?
1, like 2, like Ryan.
So Ryan,
Dang.
Listen to Ryan.
Well, looks like you're having a ton of fun.
Oh, we are. That's why the beauty of the whiteboard. So Ryan, you want me to do change, this is going to be row 1 times -2 plus row 2. Miss Babiak, how am I supposed to know what to do? You're doing exactly what I'm doing. A lot of erasing and a lot of playing around. But that could take me an hour. Well, you know when you did trig identities? Well, you are going to be
Those
doing
are
trig
way
identities again. What?
Those were way easier.
Those were easier?
They were.
Depends on who you are.
no,
I don't know.
there's gotta be some of these where you don't just.
Well, the best way to do it is on your calculator.
Then
Use a calculator.
maybe we should just learn it on a calculator.
No, you have to know multiple. This is how I look at it.
Wait,
I
wait,
always
wait,
talk
wait,
about
wait.
traffic jams, right? Augmented matrices is a traffic jam, and you have to take Highway 156, or you got to take Black Mountain Road to get home. It's your only option, but you have to persevere through it. It might take you 4 hours to get home.
Sounds very personal.
My whole take on this stuff is if you don't do at least one of them by hand, you have no appreciation for what the calculator's doing.
It is personal. It took me 4 hours to get
Once you
home
see
one
what
day
a
2
pain
years
in the
ago
neck
because there was
But
rain.
that's what we did, like,
4 hours.
Black Mountain Road.
4 hours.
Black Mountain.
I don't remember what had happened, but there was an accident on 17 or whatever, and so I had to take Highway 9, which was closed. Then I had to turn around from Highway 9. I don't know where I ended up, but eventually I was on 17. Stuck.
And at some point,
Stuck.
you just gotta say, screw it, whip out a book, pull over to a restaurant.
I couldn't. I was on Highway 17, and poor Portia was with me. She was a
Sure.
trooper. She was a trooper. Anyway,
It's a rough road to get stuck on.
get it? Rough road.
Rough road to get stuck on.
Mr. Fairman,
Hey, we have the trig meeting this Wednesday, right?
No, we do not.
We don't?
No, we have, hold on, I don't think the video wants you and I having.
Rock's always making
No, I have, no.
Okay.
It's the 11th, right?
Something like that.
Probably should though, although he probably has